So in this kit, we are providing three different type of syringes. First one is 6 ml, the next one is 12 ml, and the third one is 60 ml. So these are the three kinds of syringes we are providing in the kit. And this experiment or activity has two stages. The first one in which we are only dealing with one injection. So what you have to do, firstly, you just mimic that you are placing the finger, but the finger is little bit open, and you call any of your student to pull this down, and since the finger is not closing the hole, the student can easily pull the piston, right? In the second stage, what you have to do, you have to pull put your finger on the hole blocking the air, and then you have to ask your student to pull this. And when they are pulling this, they will face difficulty, right? And as soon as they release it, yeah, this sound, you will hear this sound and the piston will goes up, right? So why this is happening, right? Because you can ask with your students. When I ask them, there are generally answers like there is no air inside this, or there is vacuum inside this. Yeah, these are partially correct answer, but the major or the main answer for this question is that the atmospheric air, the atmosphere around this piston, which is outside, is pushing this, right? There is no air, that is correct. There is a vacuum inside this, but if there is no air, what role does it play? It is going up because the outer air, the atmospheric air which is present outside the piston, is pushing it inside, right? So this is the first experiment, and I use also an analogy, right, for discussing this. The analogy is for tug of war game. There are two teams, team A and team B, and they are pulling the rope. And I asked the student that if both the teams are applying same amount of force, suppose 10 Newton this side and 10 Newton this side, who will be the winner? Who is going to win? And there are answers like, oh, sir, no one will win, or the rope will be broken. Yeah, there are correct. This is the correct answer, that no one will win. If both the teams are applying the same amount of force, 100 Newton this side, 100 Newton this side, there will be no winner. They will remain where they are. And therefore, the same thing is happening here. There are two teams. First, the air which is inside, and second, the air which is outside. So team A and team B, right? Now, when the hole is open, the air goes inside, and therefore there are two teams which are equal, and thus exerting equal amount of pressure, and therefore there is no winner, right? But when I blocked them, I restricted team A from entering into the game, right? And now there is no team A inside, but the outermost air, team B, is present, and therefore the question is very simple. If team A is not participating in the game and team B is applying the force, who is going to pull the rope towards him? And this is the answer. If team A is absent and team B is applying the force, obviously it will push the piston inside this, right? So this is a very cool experiment to demonstrate that air do exerts a pressure. Okay, we are born in this atmosphere, and so we don't feel the pressure on our body. It is perfectly balanced. But yeah, this is a very simple experiment to demonstrate that air, even when it is not moving at a very high speed or velocity, it is exerting a certain amount of pressure called the atmospheric pressure. So this is the stage one. Now, when we go to stage 2 of this experiment, we remember a formula: P is equal to F upon A. We understand that what is P? P is pressure, what is F? F is force, and what is A? A is area. So I start this experiment by asking student that among these three syringes, which syringe has a greater amount of area. So students say that this syringe has maximum area, this has a little bit smaller than this, and this has the smallest area, right? Now I ask them that look at the formula P is equal to F upon A and judge that if I increase A, what will be the result on F? If I increase the area, whether the value of force will increase or decrease, keeping the pressure constant, because we cannot change the atmosphere, we cannot change the quantity of air around us, and therefore the P is always the constant. So what will happen when we alter or we change the value of A? So yeah, few students says that by increasing the value of area, right? By increasing the value of area, the force will increase, and few will say the force will decrease, right? So it is a very cool experiment to let them feel what is actually happening. So you can call your one student and then ask him to put the finger here and then pull it down, and he will feel a certain amount of force. Then he will go to the next one with a slightly bigger area, and he will pull this one, and then you can ask whether the force increases or decreases. So it is a very simple experiment that when the area increases, the force increases, right? So you can see that a greater amount of force is required to pull this up, and by doing this very simple experiment, student can themselves feel what you are teaching with the help of formula P is equal to M upon A, and they can directly relate with the formula. So meet you in the next experiment with another cool stuff. Thank you very much.